Hello everyone, my name is Rushali and welcome to my YouTube channel. So from today we start the binary search algorithm or binary search series in Java language in our YouTube channel. So today we'll discuss what is binary search, the binary search algorithm pseudocode and the example of binary search. Okay, so let's start. What is an binary search? So binary search means that it is an first of all it is a searching algorithm. It is one of the algorithm, right? But it is a searching algorithm. We use this algorithm to search some elements or search some target elements given in an array, right? First of all, this algorithm is apply on the sorted array only. Okay, if our array is not sorted up the if the our given array is not sorted, then we have to first sort that array, then we have to apply the binary search on that array. Okay, so first of all, it helps us to find the existence of the given target element in the sorted array. Suppose we have given an array. Okay, so in that array, if we want to find some, the indices of the target element, given target element, then we use a binary search here. We use a linear search also, but here we talk about the binary search. So we'll talk how the binary search algorithm are work in that case. So let's discuss the binary search algorithm first. If we given an target element in a given in the questions and in array also, and if you find the indices of target element in the given array, then we use a binary search here. How it is? So let's discuss here. This one is the algorithm of binary search. So how it is goes, or how it is work. So first, whatever the array is, let's take an example, like this one is the example. So here array is 5, 8, 10, 13 and 15. Their indices are here 0, 1, 2, 3 and 4, right? So we want to find, right, we want to find the element. Suppose our target element are 13, right? So we want to find the indices of the target, means index of the target element, which is 3. The index of target element is 3, right? So uh, what we do in the binary search algorithm, how we execute that this algorithm. So let's discuss here. This is an array like 5, 8, 10, 13 and 15. The index of the 13 element is 3, and we want to find the index of the 13 element, which is 3, by using a binary search algorithm. For that we use here a 3 parameter, which is start, end and mid. So how we can do the declare the start and end value? By using these indexes, right? So the first index is 0. The first element index is always 0. The array element start from the 0 indexes, right? That we all know. So the value of start is 0 always. The value of end is array dot length minus 1, which is the last element of array, minus 1. Because here there is a in array there is a 5 element, right? But the last index is 4, means the array dot length minus 1 is the last index, which is we declare, we initialize this value in the end element, right? And how we find the mid? Here we need a mid element. So how we find that? By using this formula, start plus end minus start by 2. So by using this formula we find mid. So let's discuss the binary search algorithm code, or we can say the algorithm. So here in a given method, or we can say in a given function binary search, we pass an array and x as an argument, right? So here we inside that function we declare the low as a 0 and high as a array dot length minus 1, which is the that is start and end point, right? And from till we do this all this thing, whenever like till low is less than equal to high, at that point only we do the while loop. And in the inside the while loop, first we find the mid element of given low and high. Whatever the given low and high value, we find the mid element of that value. Okay, then we check if x is present at mid or not. If x is present, then we return mid. Return mid means return that indexes, right? And if the array of mid, whatever the value of array of mid is greater than the x, if it is greater than the x, then we if you can think about it, if array of mid is less than x, Array of mid is less than x means our the target element value is greater. If our target element value is greater, then this value are exist in the right portion. Are exist in the right portion means are exist in the second portion of the array, which means we have to change our indices. Our low value is now mid plus 1 and our high value is always the end, whatever the given high value, right? Then we check the our given target element in that portion only, right? But if our x is smaller, if x is smaller, then we ignore the right half of the array and we go to the left half of the array, means the first portion. Then the low is whatever the low value, but we change the high value from this from given high value to mid minus 1, right? And like till we do this loop until our low is less than equal to high. And if we reach here, then the element was not present, right? If the element was not present, then we return minus 1, right? But if the element was present, then here we return mid value. So how we can do this? Let's discuss using that example. Here you can see the 5, 8, 12, 13 and 15, right? So if you find the value of start is 0 here, the value of mid is end is 4, right? And we find the mid element, which is like 0. Start value is 0 plus end minus start. End is 4 minus start is 0, which is 4 by 2 is 2, right? So 2 plus 0 is 0, 2 plus 0 is 2. So what is the mid value is? Here is 2, means 10 is the mid value. But 10 is equal to target. Target is our 13. So 10 equal to target. No, it is not target. 10 is less, 10, the value of mid is less than the target. If the value of mid is less than the target, then what we do? We, check on the right portion of the array. What is the right portion of the array? Is this 13 and 15 is the right portion of the array, right portion of the mid, right? So mid value is 10, the right portion of value is 13 and 15, and then we find the mid element of this both element. So mid element of this both element is because the 10 is not equal to 30 or 13, then we go like 10, then we change the value of start. The value of start is now this mid plus 1, which is 3. Mid plus 1 is 3, right? So now 3, and here value is already 4 end value. So now this what is the value? Like 3 plus 4 minus 3, which is 1 by 2, and plus this one, which is the value like 3. So now this one is 13 is equal to 13. Yes, then we return this 3 indices. So like that we do this code, right? So now let's code it. I already coded, but I'll run this code in front of you. Here you can see we first in the main function we declare an array, we declare and target value is 13, and here we print the function like find indexes, which return the integer value. Here you can see the return type is integer and the function name is find index. Here we pass the array and target element. So here we declare as an x. So n we find first the length of the array, then we declare start as 0, end is n minus 1, then we start the while loop from here, from start is less than equal to end, till then we have to check it, right? So first of all we find the mid element by using this formula. If our x equal to array of mid, then we return mid. If it is not, then else if the condition is if x is less than array of mid, means our target element is if suppose less than, our target element is less than the array of mid, which means that our array of mid is greater than the target element. Then what we do? We change the value of end element, which is end from mid minus 1, right? And if it is not, if our target element is greater than that mid element, array of mid element, then what we do? We do the change the start value from start equal to, then we start from the mid plus 1, right? And if it is exist in the array, then we return here in mid. If it is not exist in the array, then we return minus 1 at the last, right? So we'll run this code on the given array, which is 5, 8, 10, 13 and 15. Our target element is 13 and our answer is 0, 1, 2 and 3, which is right. Here you can see. the answer. So this all about the binary search codes, how we can find this the existing element index by using this algorithm. Actually this is the you know we can say core algorithm of binary search. And we only look over and mid, we only work on the mid element. If the given element is equal to the mid element or not, if it is, then we return. If it is not, then we change only the start and end value, and we do. And this is an iterative approach of an binary search algorithm. This is an iterative approach, right? And what is the time complexity of that? This code, this contain the time complexity. First, this pass whole array, right? Pass and whole array, then we pass the half proportion of the array, then again their half proportion, again their half proportion, till our array size is 1, right? So the overall type complexity of this algorithm is order of log n. If you calculate, then you can see the order of log n. And these are the this calculation are the constant time, it takes some constant time. So overall the time complexity of that algorithm is order of log n. And what is the space? Here there is a no space is needed, because this is an iterative approach of binary search. We cannot use here a recursive approach. So this contain a constant space which is on order of 1. So here are the this is the algorithm of binary search. So how it is implemented, how it is work on code also. So yeah. So now from next topic we'll discuss the another question of binary search. So till then, keep learning and keep exploring. Thank you.